All right, here for Chapter 9, we are going to look at how to control for microbes. And this is going to be both looking at physical and chemical means of control, and it is really going to focus on outside of the body. All right, not when you are actually sick, but really trying to focus on two important features. One, to keep you from getting sick. All right, simply to prevent disease, to control for the number of microbes that are in close vicinity to you, to control for microbes that could actually do damage if it gets into you. And then the other reason why we should be concerned about controlling microbes is for the prevention of food spoilage. All right, our food is dirty, all right, just like our countertops can be dirty and our hands can be dirty. Our food can actually be dirty as well, having different microbes from the air or wherever on them. And those microbes, given the chance, they're going to grow and expand. So if we can prevent food spoilage, our food stays better, longer, and it's not quite as expensive for us. And it's better for the economy in general. All right, so these are the Chapter 9 objectives specifically from the chapter. There are a couple more on your overview slide that include the bloodborne pathogens as well. But for Chapter 9 specifically, you have these first four that cover chapter or section 1. Really looking at the different terminology that we want to use so that we have proper terminology when we're looking at trying to control growth. All right, so Table 9.1 looks at just some basic terms. All right, sterilization, disinfection, decontamination or sanitation, and then antisepsis or degerming. Now, as we go down, we start at the top, we have sterilization, which is a process that destroys or removes all viable microorganisms. So everything, it is sterile. It is without contamination. And some key points there, I won't read them all, but you can look through them. But it's to sterilize things. So surgical instruments, you don't want dirty when they are cutting into you to remove a tumor or to replace a heart valve. You want all of that material free of bacteria. All right, examples of how you might achieve sterilization. Autoclaving is a good one, and that's going to utilize heat and pressure. Sterilants are different chemicals that are going to be able to destroy spores. And specifically there, we're talking about endospores, bacterial endospores. Then disinfection is just a step below sterilization. It's the physical process or chemical agent to destroy vegetative pathogens. All right, not necessarily to sterilize it because disinfection doesn't destroy bacterial endospores. So it can also play a role in removing harmful products of microorganisms such as toxins. And some examples of this are going to be bleach, iodine, heating in the form of boiling. And for disinfection, you're really looking at inanimate objects because the concentration of the disinfectant, generally a chemical, is going to need to be at a higher concentration than what is safe for human tissue. Decontamination or sanitation, cleansing technique that mechanically removes microorganisms, as well as other debris to reduce contamination to safe levels. And I like that because what is a safe level? Well, your opinion of a safe level, if you are someone who is paranoid about germs, may be very different from someone else's level of concern or opinion who understands germs and understands that germs aren't that bad for you. Okay, some are, but some aren't. So what this is really looking to decrease numbers of organisms to a public health standard. All right, so maybe the Department of Health and Health Services has a particular level. All right, there can be some bacterial contamination in our water, but it has to be below a particular number, a part per million. So it's to public safety standards is what decontamination or sanitation would be. So for this, examples are soaps, detergents, dishwashers that are going to utilize detergents as well as hot temperatures. And sanitation is important for restaurants and for dairies, for breweries, different places that actively use material that could have bacterial or microorganisms on them. All right, dairies, you are milking a cow. All right, but where are those udders? Well, if the cow is laying down, all right, the udder could be in a pile of poo because that is on the ground. And the cow doesn't know any better, maybe, to not lay in its own poo. I don't know. But you want to sanitize the udders before you go through the milking process. Breweries use microorganisms, right? They use yeast, but they need to be careful that they aren't accidentally growing additional microorganisms, different microorganisms that are actually going to destroy their products. Restaurants also need to be careful, especially if you are a restaurant that cooks meat, right? That cuts meat. You're going to have microorganisms on that meat, and then if you use the same cutting board for the meat and then your vegetables, well, your vegetables may not be cooked and therefore may not destroy microorganisms, and then you get sick. So this also can cross over to your home in your kitchen. Antisepsis or degerming reduces the number of microbes on the human skin. So this is really the one that is focused on skin, all right, animate objects. And this is going to involve scrubbing the skin. It can be, an example is alcohol, surgical hand scrubs. And so when you utilize hand sanitizer, which is basically just alcohol, right, what are you supposed to do with that? You are supposed to rub your hands together, right, because that physical movement aids in the process of that alcohol killing the organism. When you wash your hands, you should actually be rubbing your hands with the soap in between your hands with running water in order for that process of degerming to actually occur. So degerming is reducing numbers, and it usually has a mechanical means associated with it. All right, so here's a slide that is similar to the previous slide, but it adds a couple of different words or suffixes to it. So with sterilization, you're going to kill all the organisms. And if you sterilize something, it is going to be aseptic, without sepsis, so without microorganisms. And the control mechanisms here are going to have side or sidal, because it's going to establish depth. And we'll talk more about that on maybe the next slide. Nope, in a couple of slides. Then there is disinfection, just a step down from sterilization. You're not killing off endospores. Then sanitize. Sanitize actually isn't necessarily killing microbes, but rather limiting their ability to replicate. And so examples of this one might actually be referred to as static or stasis, microbial stasis, fungistatic, because it simply slows or inhibits growth at that time. It doesn't necessarily kill anything, but it prevents the further expansion of that microbe. And then antisepsis, decreasing the number of microorganisms, say, on your skin. And both sanitize and antisepsis are processes of degerming. All right, here you have figure 9.1 looking at microbial control mechanisms. And if you like flowcharts, this is a good one, because this one actually includes different information in a variety of ways. So your control mechanisms are going to be physical agents, chemical agents, and then you have the mechanical removal methods. And we'll go with mechanical because that is the least busy of the sections. And with mechanical removal, here we're talking about filtration. And with filtration, you can filter the air, you can filter liquids. And with liquids, you're able to achieve sterilization, which remember is the complete removal or destruction of all viable microorganisms, including endospores. Decontamination is the mechanical removal of most microbes. So, it's a step down. And then you have chemical agents, which can be gases and then also liquids. Gases can be both sterilization and disinfection, depending on which one you're using, and also for how long and what material you are working with. The liquids can be antisepsis if you're putting it on an animate object, so on the skin. If it is on an inanimate object, you can actually achieve disinfection or even sterilization. But again, you don't want to sterilize the human skin because skin cells are actually very similar in susceptibility to the mechanisms that you would use with microorganisms. And so if you kill the microorganisms, you will also kill your skin. So you have to be careful with those chemicals. And the physical agents, you have heat. Heat can actually be divided into both dry heat and moist heat. With dry heat, that can be incineration, which of course would then sterilize something. You're just absolutely incinerating it, destroying it. You can have a dry oven, which is going to sterilize something. And for dry ovens, and even with the moist heat, time is important. All right, putting something in an oven for 5 minutes may not sterilize it. All right, but putting it into a dry oven for a half an hour, then you could achieve sterilization. All right, moist heat, you have autoclaving, which is the steam under pressure, and that will be sterilization. Boiling water, hot water, pasteurization is simply disinfection, meaning you are destroying most vegetative pathogens, but not endospores. And sometimes vegetative pathogens will still stick around, so your milk is going to be pasteurized. But if you leave your milk in the refrigerator for, a month, 6 weeks, it'll actually go sour because there are still microorganisms in there that are able to replicate. All right, this figure just shows you the relative resistance of microbes, and you have a range of resistance or a range of susceptibility, however you want to look at it. Down here on the bottom, you have enveloped viruses. Those are going to be the least resistant, so most susceptible to these physical and chemical agents. And as you move up the list, you go up into organisms that are more resistant. And prions, if you remember, we mentioned that prions actually have to be incinerated for them to go away. You can't autoclave them, you can't boil them, they're always going to be there. So those have to be incinerated. So prions at the top, followed by bacterial endospores. Here you see that most gram-negative bacteria are above most gram-positive. Most gram-negative, just gram-negative in general, are generally more hardy, more stable, and also more pathogenic than gram-positive. And you don't need to memorize this, but simply know least and most. And this is part 1